We're on the fourth lesson of Chapter 11, which is overlapping and disjoint events. First, we're going to find probabilities of compound events. Then we're going to use a formula to find the probability of A and B. Then we're going to find probabilities of complements. So a compound event is the union or intersection of two events. And let me share an example with you for this one. Let's say you were looking to randomly pick a senior in high school. And you were also looking to randomly pick boys as well in the high school. Well, sometimes those could be compound, meaning that they're going to be related to each other. Well, that's a compound event. I'm looking for two different things. And sometimes they're going to overlap a little bit. You could actually find a senior who is also a boy. And that's where this vocab will come in. When you consider all the outcomes from two events, A and B, you often form the union of A and B. Meaning, are there any that match both criteria? When you consider only the outcomes shared by A and B, this area here, you form the intersection. That's what this is called, the intersection of A and B. So to find A and B, first you need to consider what outcomes, if any, are in the intersection of A and B. So in this example, that would have been seniors and boys. Two events are overlapping if they have one or more outcomes in common. So that's what that situation would be. Two events then are disjoint or mutually exclusive if they have no outcomes in common. And that's what this diagram shows. This would be if I was trying to randomly pick a freshman and a junior. You can't have someone who's both a freshman and a junior. So that makes these disjoint or mutually exclusive. So there's actually an equation we can use to solve these here. This equation for probability of compound events. If A and B are any two events, then the probability of A or B, so A or B would be the probability of A or B, would equal the probability of A plus the probability of B minus the middle section here. If they are disjoint events, you don't have to worry about that middle section, so you actually don't even need to subtract that after you add the probability of A with the probability of B. Let's just try a few of these problems. I think it'll really clear up once we get working on some of these. So let's look at this situation. A card is selected from a standard deck of 52 cards. What is the probability that it is a 10 or a face card? So here's our compound event. We're looking for either a 10 or we're looking for a face card. And if we follow the directions, first we need to consider what outcomes, if any, are in the intersection. Well, a card can't be a 10 and a face card at the same time. So these are actually going to be disjoint. They're not going to have any intersection. So we would have one for the 10s and one for the face cards. So I'm just going to use different colors for this because I don't have too much room. We'd have the 10 of hearts. We'd have the 10 of diamonds. We have the 10 of spades. And we have the 10 of clubs. So 4 total 10s. Then we'd have the jack of hearts, the queen of hearts, the king of hearts, the jack of diamonds, the queen of diamonds, the king of diamonds, the jack of spades, the queen of spades, the king of spades, and the jack of clubs, the queen of clubs, and the king of clubs. So if we use our formula here, we're looking for the probability of A or B. This would be A, this would be B. So the probability of A or B would equal the probability of A, which would be 4 out of a total of 52. So 4 out of 52, plus the probability of B, which would be a total of 12 out of 52. So if I add these together, that gives me a probability of 16 out of 52. I know I could divide both of these by 4. If I do 16 divided by 4, that's 4 out of 52 divided by 4, that's 13. So 413 would be my probability of picking either a 10 or a face card. Now let's look at this one. A card is selected from a standard deck of 52 cards. What is the probability that it is a face card or a spade? Now let's follow our directions. Let's find out if there's anything in the intersection. Well, can a card be a face card and a spade at the same time? Well, actually they could be. So as we draw our events, let's actually draw them so they overlap. So we would have the jack of spades, we would have the queen of spades, and the king of spades. Those would all be face cards and spades. The other face cards, we would have the jack of diamonds, the queen of diamonds, and the king of diamonds. The jack of hearts, the queen of hearts, the king of hearts. Then we'd have the jack of clubs, the queen of clubs, and the king of clubs. Now we're looking for spades over here that we haven't used already. We'd have ace, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So now let's use our formula to find the probability of A or B. If this is A and this is B, let's write our formula. The probability of A or B equals the probability of A, which would be, I count 12 in here out of 52, so 12 out of 52, plus I count 13 out of 52, then minus the combination in the middle, so minus 3 out of 52. So if I add and subtract here, 12 plus 13 is 25, minus 3 is 22. So that would give me a probability of A or B at 22 over 52. I know both of these can be divided by 2. That would give me 11 over 26. Now let's use the formula to find the probability of A and B, that intersection. It says out of 200 students in the senior class, 113 students are either varsity athletes or on the honor roll. There are 74 seniors who are varsity athletes and 51 seniors who are on the honor roll. What is the probability that the randomly selected senior is both a varsity athlete and on the honor roll? So in this formula, we're actually trying to find the probability of the and intersection. So let's write out our formula. We have probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Well, we see that 113 are either a varsity athlete or the honor roll, so that's what this would be. So we'd have 113 out of how many students? 200. And that's going to equal the probability of A will make varsity athletes A. So 74 out of 200. That'd be plus the probability of B, which would be honor roll, which is 51 out of 200. Minus, when we don't know this yet, the probability of A and B, the intersection. This is what we need to solve. So if we're going to solve for this, we need to isolate this, right? A pretty easy way to isolate this would be to move this to the left and then move this to the right by subtracting. So if we add this to both sides and subtract this from both sides, that would give us a new equation of the probability of A and B equaling 74 over 200 plus 51 over 200 minus 113 over 200. So if we do our math here, we combine these ones. We have 74 plus 51, that's 125. 125 over 200 minus 113 over 200 would be 12 over 200. So that's how many people are both varsity athletes and honor roll students. If we divide that by 4, that would give us 3 out of 50. So this is the probability that the senior you would select would be both an honor roll student and a varsity athlete. Now we can find the probability of complements. Complements are what make up the overall event probability, which is 100%. When you do an event, there's a 100% chance it's going to happen. So the probability of the complement of A, or I guess the opposite partner of A, would be 1 minus the probability of A. So think about it this way. The probability of flipping tails is 100% minus the probability of flipping heads. If heads is 50%, 100% minus 50% equals 50%. And you do have a 50% chance of flipping tails. Let's look at a dice example here. When two 6-sided dice are rolled, there are 36 possible outcomes as shown. Find the probability that the sum is not 6 and the sum is less than or equal to 9. It looks like we're looking for the complement of 6 in that case. So first we're going to look for how many times we can roll a 6. Well, I see 1, 2, 3, 4, 5 out of 36. So the probability of the complement of that, probability of the complement of rolling a 6, so not rolling a 6, equals 100% or 1 minus 5 out of 36. So if we're actually going to subtract this, this would become 36 out of 36. So subtracting that gives us 31 out of 36. So that's the probability of not rolling a 6. And you actually could count it up to make sure that we're right. Now we need the sum is less than or equal to 9. Instead of counting all the ones that are less than or equal to 9, which would be a lot of them, we can count 10, 11, and 12 and then find the complement of that. So 10 I count 1, 2, 3, 11 I count 2, and 12 I count 1. So that gives me a total of 6. 6 out of 36 is 1/6. So the complement of getting 10 or over is 1 minus the complement of getting 10 over, which is 1/6. So 1 would turn into 6 over 6 minus 1/6. So that gives us a 5 out of 6 probability that you're going to roll a 9 or lower. So let's use this example then. A restaurant gives a free fortune cookie to every guest. The restaurant claims that there are 500 different messages inside the fortune cookies. What is the probability that a group of 5 people receive at least 2 fortune cookies with the same message? This is a very unlikely thing since there's 500 total cookies. So we actually can use the complement here to actually find the unlikely probability that this would happen. We could find the probability of it not happening, which is much more likely, and subtract that from 1 to find the probability of it actually happening. So the probability of it happening would, let's put the line over it to show that it's a complement, would be 1 minus the probability of it not happening. Well, the total events would be on the bottom. So there's 500 messages for each customer. So there's 500 times 500 5 times, or 500 to the 5th. So for the first person, there's that 500 messages. So for the second person, though, there's 499 different messages that are not the same as that one. For the third person, there would be 498 different messages that are not the same as these two. For the fourth person, there would be 497, because these 3 are already taken. And the fifth person is 496. 500 times 499 times 498 times 497 times 496 divided by 500 5 times. And there we have it. 0.9801, we'll say. So the chances of it actually happening, which is the complement of it not happening, would be 1 minus 0.9801. So if we actually do that, 1 minus 0.9801, that would give us a chance of 0.0199. So the probability of it happening, we'll put H for happening, equals 0.0199. Very unlikely.